Okay, guys, so today I want to try to solve this problem, um, which is called pass sum. It's not a very hard problem, but every time I solve a similar a problem, I try to look for similar problems to see if I can deal with the different types of situations. So let's try this one. Okay. So what's the problem about, right? So this one is given a binary tree and a sum, a target sum, determine if the tree has a root to leaf path that adding up all the values along the path equals to a given sum. A leaf node is a node with no children. Okay, so, all right, so we do have a sum. We do have an example here, so let's see that. Let's test that out. So the sum is 22, and we have this tree here on the left. So the first one, if we're iterating through this tree, we'd have a 4, and then a 5, and then a 4, and then an 11, and then a 7. That totals to 27. So that's false, right? And then we would have a 5, and then we have a 4, and then we have an 11, and then we would have a 2, which is 22, which is the same as our sum, so we would return true. So how do we do this? So there are a number of different ways to do this. Two main approaches come to mind, which is one is recursive, the other one is iterative. I'm going to try to use the iterative today because I feel like it's something that I need to work more on. So let's give that a try, all right? So the way I imagine this problem is with a stack. So I can have a stack, and that basically has the current node and the sum minus the value of the node. And then I would go into some sort of loop, which I would pop from the stack. And then I would check if that node is a leaf node. If it is a leaf node, then I would check if the sum that was passed to it is equal to 0. If it is, I can just return true. If it's not, then I would move on, and then I would check if the left is not a leaf node, and then I would append that node to the stack with the running sum, let's just call it, minus the value of that left node. And I would do the same for the right node. And I think that would pretty much take care of it. So let's try to write this down. Okay. So one, I would create a stack with an object like node, and running sum, let's just call this, which would be the current running sum minus the node dot value, right? And then I would iterate over the stack until the length of the stack is 0. Then first thing I'll do inside the loop would be to pop pop a node and sum from the stack. Check if node is leaf and sum is 0. If yes, return true. If not, I would need to check if node.left is not none and append it to the stack. I'll do the same for the right node, and at the end I would return false. There is an edge case here that I forgot. I'm gonna just add it here to step 0, which is check if root node is none. If yes, return. Because if it is none and it goes in here, then when we try to pop it, we're going to try to check for its value, and then it's not going to like that. So let's try to implement this. Okay, so let's check. So if root is none, return false. Okay, done. Okay, second one is create a stack with an object. Okay, so stack equals, let's get this guy, we don't need to type this again. Root, and here is sum minus root.value, right? Because at this point, we already account for the value of the root node. So in this point, when I'm evaluating these two guys, if I'm starting with 22, this is already a 17, and this is already a 14. All right. So then, okay, so done. And then while length of stack bigger than 0, then what I do here is, yeah, so done. Pop node and sum. Okay, so node and running sum equals stack not pop. Return false. Just let's check if we don't have any errors so far. Okay. So done here. Right. So print run some just to check if this is correct. No, this is not. So I'm gonna do this differently. Node info, and then here I'm gonna get node and run sum equals node info node, node info. So this is more, this is better. Yeah. Okay. So this is good. Yeah, and we can see that this is correct because 22 minus 5 equals 17, and we're popping, and then we're done. All right. Moving on. We did this, so check if leaf node. Okay. So if node dot left is none, and node dot right is none, and running sum equals 0, return true. Again, let's run this. I like to run if possible, as much as possible, so I can catch any compile errors. So I'm done with this step. So we have a couple more. So now we have if node the left is not none, and stack, then we're going to append node left, and running sum equals current running sum minus node the left dot val. And we'll do the same for right. Right. And at the end we return false. So this should do it. So this is correct. So if node dot left is not none, then we're going to append to the stack. So here we started the stack with 1 item, and we pop it, and then it was 0, but we were already inside the while loop, so that's fine. Then it's not a leaf node, and then it's not node dot left is not none, so we append it to it, and then node right it's not none, so we append it to it. So now the stack has 2 items, and then go inside again, and then I'm going to pop it again, and so on and so forth. So this should do it. All right, so faster than 32%, not great. Sometimes you get a better one if you just run again. Oh, faster than 95% of Python submissions online. So that's pretty good, actually. In terms of complexity, so we have time. Complexity is well, it's O of n, where n is worst case O of n, where n is the number of nodes, and that's why we're going branch by branch here, and in this case we found out that the sum was true here, but maybe we could only get the true value at the end, or even if it's false, we need to go through the entire tree. So it's still it's O of n because we're iterating once. Yeah. And yeah, so and in terms of space complexity. I would say that the worst case is O of, I'm going to call depth, because the worst, the space complexity here, we're going to build a stack at most the number of levels that we have. So where D is basically the depth of our R3. And that's it. I hope this was good. I think it was. So see you next time.